Yeah, good afternoon. Afternoon for 2 minutes, everyone. 12:02, February 6th, 2024. Right, this is when this presentation was recorded. Okay, so today we're going to talk about telephony, USOC, POTS, and the 25 pair color code we're going to cover next time we see each other. All right, so let's just start. First things first. Uh, Introducing Mr. Alexander Graham Bell. I'm pretty sure everyone who lives in Canada, at least, knows who that person was. He invented the telephone when he was 29. And by the way, he was an avid inventor with an avid inventor's mind since the early years of his life. Telephone was not the only thing that he invented. Like for example, some people might not know, he invented something that's called a dehusking machine that's used in farming to separate the wheat from the straw. Okay, the grain from the straw in the wheat. So before, people used just to beat those things with the stick and hoping that they will get all the grains out of well, cones, cobs, whatever. So he automated that process. Now we can't imagine well, farming without it, right? But for the most part, he is known as the telephone inventor. His first words spoken on telephone were, Watson, come here, I want to see you. These were the first words spoken on the telephone, right? And it was in March 10, 1876. So, well, we're going to have a little anniversary coming up soon because we are in February right now. We have February now. All right, well, let's celebrate if we remember, right? Okay, good. Uh, Now, here's the interesting thing. He refused to keep the telephone in his office because he thought it was a distraction. It was something like that on his desk. Actually, it was something else on his desk, and he didn't want that on his desk. Uh, well, we know how the rest of the story went, right? With everybody crossing the street, glued to the screens of their cell phones, right? All right. So what inspired him to invent this contraption? Well, as they say, and I don't know who they are, but they do say that how does the saying go? Uh, the necessity is a mother of invention. Well, in other words, it's amazing what people will think of if they are hungry. It's kind of like a metaphoric statement. So, well, his mother was hard of hearing, and he wanted to help her. He also was a teacher in the hard of hearing. And he was teaching a hard of hearing school class. Right? So speech pathology was of his interest since early years of his life. There's more info on this here when you download this presentation and you click on that. You're going to see a little video. However, if I don't even need to give you any links. If you just Google or YouTube Alexander Graham Bell, this thing is going to light up with all sorts of information. That's if you want to get deep into some of the fascinating history that has to do with technology. And that's not only with the telecommunications or telephones, it has to do, some people are fascinated with some of the history when it comes to anything, which, it's a great thing. All right, so some of the first telephones, what did they look like? Well, here on the forefront, here we have something that's called a Centennial transmitter, and that was the first, voice transmitter that was used. Right now, apart from the telegraph, because first telegraph was invented, it was just we'll talk about that just a tiny little bit. But later on, because with the telegraph, you could just transmit contact closures and openings, so you could just on the other side, you would hear you would be able to see or hear dots and dashes, and using Morse code, you could communicate with that. Later on, Mr. Bell said that it would be great if we could actually transmit voice. So here's the Centennial transmitter. Here's a coil and a magnet inside. Here's a membrane, a microphone. You would have to speak relatively loudly to this mouthpiece or microphone, if you could call it that way. This would make this membrane vibrate, and this would move the coil around the magnet, and by Faraday's law, I think it's Faraday's law, we would get electricity generated in those two wires, and the electricity generated, the electric pulses generated by that action would correspond to the voice. And all you have to do is have something like that on the other side, that would convert the electrical signal back to the membrane vibrating, and you would have a little different piece that you put to your ear, and you would hear that. Pretty neat convention, pretty neat invention, right? Not well. The interesting thing about that is that it's hard for us to imagine not to be able to communicate over a distance. But all it takes is, well, network being knocked down, power being off, and we begin to feel the actually the lack of ability to communicate, and we feel quite uncomfortable. Once upon a time, network goes down, internet goes down, telephone lines go down. It makes us, we are so used to being able to communicate over a distance that if something like that happens, well, we are very uncomfortable with it, right? But that's what the life was before. If you wanted to communicate with someone over a distance, there will be different ways to communicate, including some of the old ways of, I think in Africa there will be those tam-tams. There'll be a bunch of like drums, and there will be a certain code of drumming that if you want to send a message from one village to another. So that was one way of doing that. Morse code was, well, maybe a different version of that. What else? You could send a pigeon, that homing pigeon, because pigeons always come home. Nobody knows how is it that they find a way, and they do. So all you have to have, if you went on some kind of a trip somewhere, you would have to get few pigeons in a cage, and if you want to send a message home, you would just strap that little piece of paper to its leg and let it go. And within a day or so, that thing would find its way to the cage, and somebody would read your message. What else would there be? Smoke signals by the native communities, in North America, right? That was a way of communication. In some of the earlier, I think would be World War One or one would be still. It would be the flag system. There would be a person waving flags in a certain way, and they would, well, relay a message, but somebody would have to see it with binoculars. So there would be a ship-to-ship communication and things like that, right? So people were always striving to communicate more efficiently and over a distance. And of course, you could send a letter, right? You would write a letter. There was such thing as the art of writing letters, right? You would want to communicate with your friend who is in another city. You would write a letter. You would put it in the mailbox, and maybe a week from now or something, the letter would be on your friend's home, uh, in like, I don't know, in Toronto or Windsor. Okay, now we just write an email, we just text. So we have evolved. But if we just imagine during those times when this thing was impossible to do, and all of a sudden it is possible to communicate with someone on voice. You don't have to send a pigeon, you don't have to send a letter. uh, you could just talk in real time with someone on the other side of the city. Right? Later on, things were improved. You could talk to someone in another city. You could talk to someone in another country, and then you could talk to someone on another continent. It was a huge deal to make that change, to the point that, look, here is, what do I say here? An actor portraying Alexander Graham Bell in 1926, silent film, right? There's silent film. It shows Bell's first telephone. Okay, they were making movies about using a telephone, right? Which today is kind of sounds a bit silly, but that's how big of a deal it was. Right? And funny thing is that the movie was silent. It was about using a telephone, right? So technology moves a long way, right? Moved a long way. So that was one of the first telephones, and you could probably see that in some of the black and white movies. That all people used to wear suits, and ladies would wear dresses. It was interesting times, and those telephones would be, well, in some of the aristocratic homes because they were the ones who had money. Funny situation. It was presented in a funny way. If anybody watched the series that was called Downton Abbey, the invention of telephone is noted in that series, and there were a couple of funny situations that, well, the phone rings and nobody knows what to do. Somebody picks it up and says hello, and oh, wow, he knows what to do with this contraption. And then the person says, "Oh, he's not here at the moment. May I take a message?" Wow, the people were in just awe, like he knows how to go about this whole thing, right? Well, think of the whole thing today, right now, in today's time. It's a normal thing, right? All right, let's move on to the next thing here. There's some kind of, there's some kind. Look how cool it was to own a phone. This is a phone. And look how proud this person is to use the phone, right? Look, just take a look at how this thing looks like. Here is a microphone with a membrane. You would scream to it, and you would put that tin can something right to your right to your ear, right? So you could talk to someone, right? Then, of course, Mr. Bell would demonstrate using a telephone. People would dress up, and they would have, it was a big deal, demonstrating on how to use the telephone, right? Now, is this a big deal for us right now? I would like to point that yes, it is a big deal. Still, how do we know it's a big deal? Well, when somebody pulls the cord and then we don't have it all of a sudden, then we realize how big of a deal it is. Now, early telephone exchange, things had to be organized in a certain way. Right? So, uh, you will hear terminology such as CO. Here's the CO. CO stands for central office. And the telephone lines used to be called CO lines. Let's get the CO line delivered to so and so house, or such and such house, or residence, or maybe a restaurant in New York City or somewhere there. Right? So it just stayed, the terminology stayed that let's get some CO lines. Here's a CO line. How many CO lines do you need? And that terminology is still being used today. Now, the central office, the CO, used to look like this. All the phone calls were patched manually. There was no automatic switching. So there would be a telephone attendant. This probably would be somewhere in a smaller town. And this here would be in a bigger city. So there was a whole workplace culture associated with that. All right. So when somebody would want to make a phone call, they would not dial because dial was introduced later on. Maybe I can give you a little bit of a. There was a movie on instructional movie, black and white, old movie on introducing the dial tone because there was no dial tone. You would pick up the phone, you would get it off hook. You would get this thing off hook. That's what, because this thing was a hook. So you would take the earpiece off the hook. So you could say, oh, the phone is off the hook. You would take the phone off the hook, and the telephone attendant would see a light up on your circuit. And you would not hear the dial tone because it wasn't existing at that time. You would hear something like a number, please. Right, number, please, number, please. I wonder how many times those lady attendants would have to say per day, number, please. But that's what you would hear instead of a dial tone, and you would just say whatever number you want to talk to, and you would be patched. As soon as the telephone is hung up, then another light would light up, or whatever it was made as to be. I just okay, uh, uh, and then the attendant would terminate the call. Now, see those little cords here? Those cords used something that's called quarter-inch jacks or quarter-inch plugs. Well, jack is the female part of it, and plug is the male part of it. Okay, and it's called quarter-inch because the diameter of that banana sort of plug is quarter of an inch. That's the diameter of that plug. Now we're still using those. And the guitar players here or musicians, you will see quarter-inch jacks or plugs all over the place, still being used today. Now we also have another version of that is an 1/8 inch jack or plug, and it's one over eight, 1/8 of an inch. Uh, it's a smaller one. That's the ones that we use for our earbuds, ear headphones. Okay, earphones. All right. So, and from all that workplace culture and whatnot, right now, that's what the central office looks like right now. Okay? In fact, you see some of the buildings in our area would be marked as Bell Canada or Bell, uh, and it would be just a building that is just standing alone, no windows, and nobody's in there. Just when somebody needs to go and service things, and all this switching happens automatically. All right. Now the tech stuff. Let's look at the tech stuff. That was the patented by telegraphy, but the telegraph, and then see this would be just to close the open the switch, and you would hear the dots and dashes. But this one here is the telephone that would have a membrane here. When you speak to this mouthpiece, the membrane vibrates. It moves the coil around a magnet, and that creates electric signals in the wire. Now here you would have one wire going per telephone conversation. The return path of the ground reference was actually provided by ground itself, and here would be something that's called a battery to boost the strength of the signal. Otherwise, you just wouldn't be able to, the signal would not be strong to go from one end of the city to the other. And the battery was, well, 48 volts, about 50 volts, DC. Okay, now notice that is here a very interesting thing. Look at this battery here. In a DC source, the symbol of the battery is represented by those long dashes or prongs and the smaller bars. The shorter bars represent negative side of the DC battery, and the longer side represents the positive. So here's negative, here's positive. And look, the positive side of the battery is connected to ground. All right, so so this here line will sit at negative 48 volts in reference to ground. The signal line is more negative than ground. The reason for that is it used to be the other way originally. Right? All the telephone lines, the telegraph or telephone lines would be positive and the negative would be connected to ground as a ground reference. The problem was that those copper wires would corrode too much. There was a big problem with corrosion. So somebody tried to get a solution for that to see what if we reverse the polarity of that. So we would make the positive side of the battery equal to the ground potential, and then we signal one which is negative, sitting on the negative potential, it would reference to ground. So it's more negative than ground. Okay, that would stop the corrosion. So that's the only reason why that thing is the positive and the negative, and the positive is equal to ground. I will ask you on the test. Yeah. It will be on the test. Not maybe, it will be. You will have a question like that. All right. So of course, this would represent something like a telegraph station. Before telephone was widely used, the telegraph was widely used. And then when the telephone was introduced, it was both. You could send a telegraph message, and where would those offices be located? Well, they would be located by the train station. I think it was that movie, old Western movie, Once Upon the Old West or something like that. And the opening scene is in a train station, and you can see the telegraph equipment right there. In fact, they wanted to interrupt the communication because they were the bad guys. So the first thing they do is they destroy the telegraph so the communication could be interrupted. So why would those be in around the train stations? Because the pathway for the wiring was already established because of the rail tracks. So by the rail tracks, you could just all you have to do is just put those telegraph poles and extend the wires there, and you have the pathway established. Okay, and here is a example of a Morse code. Dots and dashes, very popular still upon the Second World War. It was widely used to communicate because it doesn't take much bandwidth, and you could transmit using short waves. You could transmit that thing all over the world. Short waves reach far. In fact, you can ping yourself with shortwave radio. If you just send a ping signal, it will go around the whole Earth, and it's gonna hit you in the back. All right, it's gonna hit your antenna after coming, basically traveling around the Earth. Okay, and it might take a couple of seconds to do that. All right, so here is the Morse code example. It was used. All right, now Morse code was still used in the modern times. I would say. I think the last official transmission, military or otherwise, was transmitted sometime around 1991, and that was it. The Morse code was abandoned as far as official way of communicating. You can, if you get yourself a shortwave radio, or if you log in on your browser to any of those shortwave radios, virtual shortwave radios, they're connected to real transmitters and well, actually receivers, and you can control the dial of the radio to listen to some of the shortwave or otherwise waves bands from all over the world, right? And sometimes you can still hear some of the Morse code being transmitted by the amateur radio enthusiasts. Yep. And this would be what the telegraph or telephone poles would look like. You can still see some of the residues if you drive out of town, and you can see some of the rail tracks. You can see still some of the old, unused already, just standing there, being silent because they do not transmit any messages anymore, but they used to be really busy. And you can still see some of that. So if you're a photographer or some kind of a documentalist, you might want to take some of the pictures. Pretty good art. Uh, um, Sentimentality, as I call it. All right. Now that's another version of what they would look like. This would be around the along the road, and but for the most part, it would be along the railroad tracks. And if you want to get even more sentimental about things, here is a song that's called Telegraph Road by Dire Straits. So once you download it, you might want to click on that and just relax and listen to the, as I say, the sentimentality. All right. Let's get to the tech stuff. Again, USOC. USOC stands for Universal Service Ordering Code, and it has to do with the way of wiring, the wiring code. Uh, Notice here, there's a phone jack. It says RJ, and you will hear that a lot. RJ11, RJ12, RJ45. RJ45 is actually the computer Ethernet plug. RJ stands for registered jack. Where does that registered part come from? Well, in the old days, just as the telephone was taking off, was the new invention, and it was just becoming more and more popular, there would be some companies that would invent their own way of making connectors, their own way of making connections, their own way of interfacing one thing to another, and it was just becoming too much of an unregulated mess. So when the telephone lines became way too popular to be ignored, then some sort of standards had to be introduced so the manufacturers could produce certain type of paraphernalia, equipment, and anything that goes with it, right? So that's why we have the RJ for registered jack. Now, RJ11, here's the footprint of RJ11. Notice one thing here. See those prongs here? Here is pair 1. Remember, pair 1 always is in the middle. Pair 2 goes outwards. So this one here, this jack RJ11, is capable of carrying 2 CO lines. RJ12 would be just the same, but it would be, see those slots here, they would not be empty, they will have 2 more prongs. So that's the difference between RJ11 and RJ12. By the way, RJ45, which is the Ethernet jack, will physically take the RJ11 or RJ12 jack or plug. So you could have a bunch of RJ45 jacks installed on a patch panel or on a desktop or in the wall. And if you wire them at the back certain way, you could use those jacks also as telephone jacks, but they have to be wired differently, not as Ethernet. And they, of course, they have to be connected to the telephone equipment instead of the data or Ethernet or LAN switches or routers or whatnot. Okay. All right. Can we do the next slide here? Yes. Here is the tip and ring. Remember when I was talking to you about the telephone attendants in the here, come on. Oh no, too much. Here, there you go. When I was showing you these, right? Those are the 1/4-inch jacks and plugs. Oh, come on. I just have to wait for that. There you go. That's what those endings would look like. And if there's any guitar players or musicians, they will be very familiar with this type of thing. There are 2 types of jacks. One is tip, ring, and sleeve, which has 1, 2, 3 connections to it. And of course, you would wire them up accordingly. And some of them are just a tip and ring. Sometimes some people call it tip and sleeve, but tip and ring is the most popular one. which is basically this one here is eliminated, one of the prongs, and we just that part and that long other part here. Some people call it stereo jacks and mono jacks in the music industry. Now, see here, remember when I was talking to you that the positive side is equal to ground? The phone line, the CO line, the POTS line, which stands for plain old telephone service, POTS. Okay. Well, here's one thing, So, what did you learn in school today? Oh, we learned about POTS. Yeah, we learned what? Okay. So, POTS stands for plain old telephone service, and that means it's the telephone service delivered in the most basic way. Right? Pretty much, well, POTS is POTS, telephone line. Right now, see, excuse me. The positive side of the POTS line is equal to ground. It's actually connected to the ground, and there's a negative 48 volts introduced to the whole line. Now, tip and ring. Tip is positive with the reference to the ring. If it was just a tip and ring, this one is tip, ring, and sleeve. But the tip is equal to ground. And this one here is going to be just more negative towards that. So this negative side of the telephone line is more negative than the ground itself, because that's how the battery is connected. Right? Then when you add 90 volts AC to it, you're going to get the phone ring. So when the phone line idles, there's a constant DC going there in that jack, and it's 48 volts DC. That 48 volts is always there because that 48 volts is always there even if the power goes down in your building, because that line is independent of the power grid that's supplying the power to your house or office. That power is provided by the battery system that is provided from the central office, from the building where the lines are coming out of. Please remember that. So when the power goes down and you have a POTS line, you can still use the phone, providing that the line is not cut somewhere, right? Now, there's a short YouTube video I made. I don't know if it's like 1 minute or 2 minutes or 3, I don't remember. Click on that link and it's going to show you. I used the multi-sim to visualize the it says telephone line voltage simplified. When it idles, there's a constant 48 volts, actually negative 48 volts. When the phone rings, there's a 90 volts AC introduced, and the telephone circuitry has a way to sense that and make the phone ring. So when the phone rings, there's a 90 volt AC, and it doesn't ring. Rings, doesn't ring. That's why, sometimes you go ring, 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 depends on when this thing is present, the phone rings. So yeah, it's, is it dangerous? Well, it's difficult to say it. Anything is dangerous depending on how you apply to your body, right? For the most part, if you just touch that telephone line, it might get a little bit uncomfortable when you feel that, especially when the phone rings. Okay, but what's dangerous, what's not, it's a relative thing. As I said, it depends on the situation. It depends how it's applied, and this thing is it's not capable of delivering a huge loads of current as well. And what makes electricity dangerous is the power, with the voltage and current. Voltage itself, yes, it can kill if it's a lot of voltage, but then the current. So is it dangerous? Well, everything is dangerous. Okay. All right. In its own way. Now here is USOC configuration. All right. The old color code system, which would be green, red, black, yellow, and there was also white and blue. If there were three pairs. Pair one, green and red. Pair two, black and yellow. Pair three would be white and blue. It was the old way. Okay, now some that's called a quad wire, and quad wire is a wire that is used still in the alarm system, security alarm system industry, and the quad wire is not twisted. That's not very recommended to be used with phone line conversations because there is such thing as crosstalk, and we will talk about that as well. Um, Telephone lines have, they're considered to be category 3, which is kind of obsolete now, but you can still get some of those cables. You can use them for intercoms, an analog way of transmitting intercom, or so the cat 3 would be slightly twisted in order to eliminate the crosstalk. And we will talk about that in greater detail in further lectures. Now here, most of the telephone lines are being connected with the Cat5e cable just because we can. And the other thing is that try to get telephone wire, try to buy at any distributor, try to get just a Cat3 telephone line. It will be have to for the most part it will have to be a special order. Cat5e is the lowest available right now, widely available. Almost over the counter at any distribution store or hardware store, and it can be used to connect telephone lines. How do we convert the old color code to the new color code? Well, these are the first 1, 2, 3 pairs of the 25 pair color code. And it says modern color code, unshielded twisted pair. We'll talk about that too. Right? Here's the pin destinations. If you look at the jack, if you're looking at the wall, you see a jack. Here's how we count the pins: 1, 2, 3, 4, 5, 6, from left to right. How do we count the pairs? Is using the USOC configuration. We just go pair 1 in the middle, pair 2 is outwards, and pair 3 is even more outwards. So you just travel outwards, and this is how we count the pairs. And look, here is tip and ring. Here is tip and ring. And here is tip and ring. This is not just a random tip and ring arrangement. In USOC configuration, this is how the tips and rings are arranged. So if you look at the tip, so here's tip 1 and ring 1. A telephone line number 1. Here's telephone line number 2. Here's telephone line number 3. Okay. Now, this here jack, this will be RJ12 because it has 3 pairs. Is capable of carrying 3 telephone lines. Are we connecting this thing now like this? Not really, because there used to be some old telephone systems that would employ that kind of configuration. Now things are different. If there's a telephone jack, it's just using, if it's like a POTS telephone jack, it's just using the middle pair. So I'm going to give you an example. Where's my board? There it is. Okay, so here is a telephone jack. All right, and it has pins. Right, let's say this one is RJ11. I just drew them like that. Here's another telephone jack, and it also has pins. All right, and here's another telephone jack that has pins. Yeah, pair 1, pair 2. Okay. Now let's see. Let's say you're going to have a Cat5e cable transmitting 4 pairs. Well, and those pairs, pair number 1, pair number 2, pair number 3, and let's say there's pair number 4 coming out of it, right? So blue, green, orange, brown. Pair number 1, I just drew one line, but that's a pair of wires, okay? It could be connected to line 1, telephone line 1. This could be connected to telephone line 2. This could be connected to telephone line 3. And this would be just wrapped around or just left unused. Now we have those 3 pairs coming on the other side, okay? All right, well, let's see here. The telephone is looking for the line, is looking for a signal in the 2 middle prongs. That's where the regular telephone line or telephone set is looking for the signal. So here would be a telephone. All right, here will be a telephone. And here will be another telephone. All right. Okay. Now, so here we have the blue. Here we have the orange, for example, and here we have the green. And there will be the brown pair here that's not used. All right, so we have the blue here. We have the orange on the other side, and we have the green. The blue will be connected to the blue pair of the jack because that's where the telephone is looking for the signal. Now, we have another pair, another telephone line, another single line, it's called SL, single line, coming on the orange pair. And we're going to connect this thing to another jack. Well, we would still connect that thing to the, even though it's orange pair, we don't care. It's a telephone line carrying a telephone signal. We physically have to connect this thing to also the blue terminals of this jack because that's where the telephone is looking for signal. If you connect it to orange, the telephone will not find the signal because it will physically not be connected. And you guessed it, if anybody did, the green pair, if it is to be wired as a telephone jack, it also has to be wired to the blue terminal, and that's it. When you plug in the regular telephone set, the POTS telephone set, or SL set, single line set, it's another name for it, it will be looking for the 2 middle prongs. Okay. It will also be on the test, but never mind the test. You just get the marks or marks deducted. You will have situations that you will be connecting things like that. There will be requests, for example, in retail business, very popular thing to do. One of the cash registers becomes the failover cash register, and it will be requested that maybe you will have 2 telephone lines connected to that underneath that cash register. One for a regular phone, and sometimes it's called a 911 phone. It's just a regular phone. So when all the power goes down, all the network goes down, your phone system goes down because the power goes down, whatnot, you still have that one CO independent line connected to that point. So you could just connect all telephone for $9 that you could buy at whatever Walmart, and you can still dial out. Right. Another one could be designated, another jack could be designated for a failover money machine. You know, the credit card machine, the debit machine. I don't want to use any brand names here. Right? It's also a failover. If network fails, then the money machine switches over to a dial-up communication, and it's pre-programmed and so on, instead of communicating over network. And maybe you're going to have a request for another telephone line for whatever reason. So that's how you would connect. If you connect phone lines, and you can use the RJ45 data jacks physically, you're just going to use the blue pair only to connect telephone signal to. Okay. All right. So let me here. All right. Now let's move on. Here's another visual of things, and pay attention to the polarity of the tip and ring. See here, tip and ring. This would be a positive with reference to that. Okay, but even though this is more positive, the tip is more positive than the ring, the tip would be at the ground level, and this would be more negative. Just look at that diagram here, watch this video, and you might have to look at this thing more than once until it actually you get the light bulb in your brain. I got it. Okay, learning things is all about many light bulbs, and sometimes the light bulbs come quicker, and sometimes I have to read certain things few times and analyze things in my head before I get the light bulb. Right. All right. Here is a typical RJ14. Now this RJ11, RJ12, RJ45, whatever. The numbers don't mean anything. They are just designated catalog numbers and the model numbers of that. Okay. And look, here we have the jack, we have the green and red, and black and yellow. This is capable of two lines, but for the most part, just the green and red are going to be used. Here is something that is called a demarcation point. You can see this on the side of the house or on the side of, if there is a telephone line pulled up. This one is capable of two telephone lines. Look, oops. I was trying to zoom in. Just take a look. Here's line one, here's green, and here is red. See that? Here's line two, green and red. These wires are connected to these jacks. Now, the telephone line would be brought in from the outside through this little kind of like a connector or interface here. So we just pulled in here from the city, from the central office, and it would be one line be connected to this red and green here, and line two would be connected. So this is capable of having two lines. If you put more inserts here, you could add one more. You could add one more line to the top slot here. Maybe two more lines here could be added. Here's a slot for one more. Here's a slot for one more. And, well, you got two more here capability. Right? But this one here, as it is wired, as it is configured, two lines capability. Now, these two are connected to this jack, and you can just unplug it and plug that. And from here, see red and green, that's where the line goes to the rest of the house. What is this prong here? This is a ground. Everything has to be grounded. Okay. Now, this little thing here is to connect and provide a lightning protection for the coaxial cable. But this ground here is this part here should be grounded, connected to a true ground. And this little plastic looking part is made out of material that is acting as an insulator. However, if you get a huge voltage jolt like from a lightning, this thing will conduct and will take the hit and connect the electricity to the ground instead of passing through to the rest of the house. So the equipment in your house should be safe, right? There's that little catch, and I hate the word caveat, but that's the only word I can use here. Why do I hate the word caveat? It's because it's overused, becoming a cliche thing. The caveat with this thing here is nothing, there's no guarantees. But, and I also, it's not my favorite saying, it's better than nothing, because sometimes nothing is better than something. It depends on the situation. But that's just the way it is. It works for the most part, because sometimes you don't get a direct. If you get a direct hit, like no lightning protection is going to help you. But you don't always get direct hits, and sometimes this is, for the most part, it's enough, or something's being done about it to minimize the effect of a lightning. So this is a lightning protection, and by law, you need to have lightning protection even if any communication wire, even if it leaves and comes back for 1 inch out of the house. Right? Okay, so this will be the last slide for today, and we'll pick it up on the next lecture. And with some of you, I'm going to have it in person, and with some of you, I'm going to have it online again. So that means that all the lectures for this semester will be available online. And as you can see, our YouTube playlist is being populated. Okay, that's it for today. And if there's any questions, shoot. If not, I will talk to you when I see you in person. Thank you very much. Bye.